Okay, so today we're going to look at empirical and molecular formulas of compounds. So the empirical formula is known as the simplest formula. It shows the lowest whole number ratio of elements in a compound. So for example, if we have something like C6H12O6, the empirical formula would be the simplest terms. So that would be reduced down to CH2O, because you're looking at the ratios. Right here it's a 1 to 2 to 1 because it comes from 6, 12, 6. Now of course we don't put in the ones, so this would be considered the empirical formula for sugar. The molecular formula is the actual formula. So if we look at that example again, C6H12O6, this would be the molecular formula. Whereas CH2O would be the empirical. And the molecular formula describes the number of atoms of each element that make up the molecule, or formula unit. So when we look at some of these examples, H2O, molecular formula, its empirical formula is the same, that is the lowest ratio. It's a 2 to 1 ratio. If you have something like H2O2, however, in lowest terms, lowest ratio, it's a 1 to 1 ratio. You have 2 hydrogen for every 2 oxygen. So its empirical formula is HO. C6H12O6, like I said, CH2O, it's a 1 to 2 to 1 ratio. Something like C6H6, it's a 1 to 1 ratio. C4H4, 1 to 1 ratio. So if you look, C6H6 and C4H4 have very different molecular formulas. However, they have the same empirical formula. Something like C6H7N, that is in its lowest terms. So you have 6 to 7 to 1, 1 being the nitrogen that's present. As seen in the previous table, you can have the empirical formula and molecular formula be the same, as in this case, H2O and H2O. And as seen in that table, two molecules can have the same empirical formula. So C6H6, C4H4 have the same empirical formula of CH. It's a 1 to 1 ratio for both. So basically, the whole idea behind this is the empirical formula tells you the elements in the compound in the lowest ratio, but does not give you the percent composition. So remember yesterday we talked about percent composition. We don't know what percent of a certain compound is carbon or what percent is hydrogen. So it does not give you the percent composition. Now, sometimes you may have to determine what the molecular formula is, and you can do that from the empirical formula or vice versa. So if you are given N representing any number, okay, not number of moles, but any number times the empirical formula. So what we have here, if you have the empirical formula of CH, molecular formula 2 times that would be C2H2. Now where does this help us? Where is this useful? So let's look at an example. If you calculate the empirical formula of a compound that is 85.6% carbon and 14.4% hydrogen. So when we're doing these, we're going to assume a total mass of 100 grams. So 85.6% is carbon and 14.4% is hydrogen. So that means if we're assuming a total mass of 100 grams, well then that means 85.6% of that will be 85.6 grams. And 14.4% is hydrogen, that means 14.4 grams of hydrogen is present. Now that we have the mass that's present, we also can calculate the molar mass of carbon, 12.01 grams per mole, molar mass of hydrogen, 1.01 grams per mole. Now we can calculate the moles of each one, because number of moles equals mass over molar mass. So when we do that, we find the number of moles of carbon. Remember, number of moles equals mass over molar mass. We said we're assuming 100%, so 85.6 grams divided by 12.01 grams per mole, mass over molar mass, gives us 7.13 moles. Just get rid of this. If we do the same with hydrogen, we have 14.4 grams divided by its molar mass, 1.01 grams per mole, and that gives us 14.3 moles. So what we do with this information now, we identify the lowest mole value, divide both with it to find the ratio. So if we take these, the moles of carbon is lower than the moles of hydrogen. So we take that lowest mole value and we're going to divide both. So we said the lowest mole value was 17.3 moles. So 17.3 divided, or 7.13, sorry, divided by 7.13 is 1. And if we take, I'm just going to go back. Remember, this is where it came from. We calculated the number of moles. So 7.13, 14.3 for hydrogen. So 7.13 for carbon divided by 7.13 moles, it's 1. For hydrogen, 14.3 divided by 7, so it's approximately 2. What that tells us is that the ratio is going to be a 1 to 2. So that means the empirical formula is CH2. So there's 1 carbon for every 2 hydrogen. Empirical formula is the simplest form. Molecular formula is the actual. So back to this, which I didn't really explain, if you know the molar mass of the molecular formula and the empirical formula, then you can determine the molecular formula. So let's say that again. If you know the molar mass and you know the empirical formula, you can then calculate the molecular formula. Let's look at an example. A lot of times the molar mass is used or is calculated by actually using a thing called a mass spectrometer. And this is just a device to find the molar mass. So a lot of times the questions that you will see will tell you what the molar mass is from a mass spectrometer. So if we look at this example, it tells us, remember, write down what's given. The empirical formula of sugar is CH2O. So empirical formula CH2O. We're told a mass spectrometer found the molar mass of sugar to be 150 grams per mole. So molar mass is 150 grams per mole. Now we want to know what the molecular formula is. That's what we're looking for. So we're given the empirical formula, we're given the molar mass, we can now find the molecular formula. Given the empirical formula, we know the molar mass of the molecular formula. It was given to us. We can calculate the molar mass of the empirical formula. So we have 12.01 for carbon, 2.02 for our 2 hydrogen, and 16 for our oxygen. So that gives us 30 grams per mole. So now we have 2 lots of molar mass and an empirical formula. Remember, we are looking for the molecular formula. We have the empirical. We were given the molar mass of the molecular. We calculated the molar mass of the empirical. So with that, you have the molar mass of the molecular formula, the molar mass of the empirical formula. When you divide, that gives us a number of 5. This is that N value that that showed up back here, and I didn't really talk about it because it wouldn't make sense back there. But now this is that N value that we were looking for. Okay. So when you divide the molar mass of the molecular formula by the molar mass of the empirical formula, you get that N value. So in this case, the N works out to be 5. So here we see this formula again. N we calculated as 5. So we have 5. We said the empirical formula was CH2O. 5 times that gives us C5H10O5. And that is our molecular formula. Now you're probably saying, what? But have a look at this video again, okay? Try to figure it out, and now you can work on pages, anything in your workbook up to page 87. If you're still having trouble with this tomorrow, I can go over it with you again. Have a great day. Sorry I couldn't be there, and see you tomorrow.